Let's start. We have limit as x approaches 0 of -1 over x squared times x plus 1. So here, if I pick numbers really close to 0, so we can think of picking numbers to the left of 0 and to the right of 0, we know that we're going to have at the top a negative number, and at the bottom the x squared. Whatever we put in for x, it's going to be positive, but small. And so that's for x squared. And then for x plus 1, it's going to be positive, but it's going to be really close to 1. Right? So a really, really close number to 0 plus 1 is just 1. So negative divided by positive, that will just give us a negative number. And that will just be over a small number. So a number over a small number will go to infinity, and so the sign will be negative. So it'll be just negative infinity as my limit. So next, if I have limit as x approaches 0 from the right of 2 over 3x to the 1/3 power. So because I'm looking at 0 from the right, I'm going to pick numbers to the right of 0. So think of it like 0.01, 0.001, etc. Well, right now I have, at the top, I have a positive number. The 3 is positive as well. And if I do a cube root of a positive number, that's also going to be positive. And it's going to be small. So it's going to be a very small positive number. And here, positive over positive is going to give me positive. And any number divided by a very, very small number will go towards infinity. So this limit will go to positive infinity. Next, if I were to look at what happens to this limit as x approaches 0 from the left, I would pick a number very close to 0 from the left, so it could be like negative 0.01 or negative 0.001, etc. What happens is I have a positive number, so we can have a positive number at the top. The 3 is positive, but then I'm going to be taking a cube root of a negative. So cube root of a negative is negative, and then since we're getting very, very close to 0, the cube root of that is also going to be really close to 0. In other words, it's going to be very, very small. Now the positive times a negative, so these are just going to be negative, and then the positive over negative is going to be negative, and any number divided by a super small number is going to be infinity. So the limit here, as x approaches 0 from the left, is negative infinity. So from the right, we found it to go to positive infinity, but from the left, it's going to negative infinity. Okay. All right, let's look at a similar problem, but now instead of doing the cube root, what happens if we look at the fifth root? So if I have 2 over x to the 1/5 power, I know 2 is positive, so that's good. And then I'm going to be picking numbers to the right of 0. So again, we can think of like 0.01, 0.001, etc. So we'll be taking the fifth root of a positive number, so that's going to be positive. And because we're getting really, really close to 0, when you take the fifth root of that, it should also go close to 0. So in other words, it's going to be small. We know positive divided by positive is going to be positive, and any number divided by a super small number is going to go to infinity. So this limit goes to infinity. Let's compare that to if we have a limit as x approaches 0, but this time from the left of 2 over x to the 1/5 power. We'll have a positive number, But now we're going to be looking at x values to the left of 0. So like negative 0.01 or negative 0.001, etc. So because we're taking the fifth root of a negative number, the answer is going to be negative, and since we're choosing x to be very, very small, the fifth root will also be really small. So now we'll have a positive divided by a negative will give us a negative number, and a number divided by a small number will go towards infinity. So this limit is negative infinity. And from the right, we saw it was positive infinity. From the left, again, it's negative infinity. So there's something to it when you have a cube root or fifth root or a odd root. So it looks like when you have an odd root, the limits are going to be different, versus the even root, the limits are going to be the same. So let's look at an example where we have an even root. So if limit as x approaches 0 of 4 over x to 2/5. Here, the only reason I'm saying even, it's not necessarily the root is even, because the root is a fifth root, but we have a square in the numerator. So it's really like x squared. So that's going to make things positive. Okay, so the idea here is, in general, with the limit, you want to look at to the left of 0 and to the right of 0. And here it doesn't matter, because whether I pick, let's say, negative 0.001 or positive 0.001, the square in the denominator is going to make it positive. So the values are going to be the same. So it doesn't really matter. So what I'm going to have is a positive number over a positive number, because when I take the number, square it, it becomes positive. And once you take the fifth root of a positive number, that's still going to be positive. And because I'm getting closer and closer to 0, in both directions, I'm going to be taking a square and the fifth root of a very small number. So I'm still going to end up with a small number. And now a positive over positive is going to be positive. And since I'm dividing a number by a small number, that's going to go towards infinity. So my limit here is infinity. Let's look at a similar one. If I have limit as x approaches 0 of 1 over x to 2/3, I again have the 2 in the numerator, so think of that as x squared. So that makes things positive. So I'm just going to have a positive number regardless. And I'm going to pick numbers really close to 0. So I'm going to take that number, square it, turns positive, cube root it, still going to be small. So positive over positive is positive, and any number divided by a small number, that's going to go towards infinity. So my limit would just be positive infinity. Okay. Next, let's look at some trig limits. So let's say we have limit as x approaches pi over 2 from the left of tangent of x. Let's see. First, if we know the graph of tangent, tangent, there's the asymptotes at negative pi over 2 and pi over 2. And it's going to look like this. So if we approach pi over 2 from the left, we're just coming in from the left here, and you'll see it's going to positive infinity. So the limit is just positive infinity. So that's the easiest way to do it. Another way to think about it is, well, we can have tangent as sine over cosine. So we can have limit x approaches pi over 2 from the left, sine over cosine. We know sine of pi over 2 is just 1, so you'll have a negative 1 at the top. And cosine of pi over 2, we know cosine of pi over 2 is 0. And cosine, so if we look at the unit circle, pi over 2 is here. So cosine is 1 here, and it gets smaller and smaller. So it goes to root 3 over 2, root 2 over 2, 1/2, and it just gets closer and closer to 0. And the values here of cosine are going to be positive, right? So it's going to be positive, but it's going to be a very small number because it's going to end up going to 0. And we'll have a negative number over a positive number will just give us a negative number, and then 1 over a super small number will go towards infinity. Alright, okay, so there's a mistake here. This pi over 2 is going to the left, so this is not right. So this pi over 2 is from the left, and so this is positive. So this will just go to positive infinity.